Bismillahirrahmanirrahim. Topical question paper, part 6. In this session, we will solve 10 sample questions and the topic is current. Course is Cambridge O-Level Physics. Course code is 5054. Let's start the questions. Question number 1. Ohm's law states that the current in a conductor is proportional to the potential difference across it, provided that a certain quantity remains constant. What is that quantity? That quantity is temperature. Question number 2. Three identical heating elements are wired up to the main supply in the three arrangements. In which arrangement is the current from the supply lowest and in which is it highest? So you can see three arrangements as X, Y and Z. X is a series arrangement, whereas Y is the parallel arrangement and Z is the series parallel combination. So remember one rule of thumb. The series arrangement will offer the highest resistance. That means in series arrangement, the value of the current will be the lowest. So this is one of the extreme case that the series arrangement it will offer the highest resistance and the value of the current flowing through this arrangement is the minimum. Okay, the another extreme case is for parallel combination. So in parallel combination, the total resistance will be the lowest and the current flowing through this arrangement will be the maximum. So it is another extreme. That is the resistance that the parallel arrangement will offer is the minimum. Hence, the current flowing through this arrangement is the maximum. So this is another extreme. And remember, all other different variations of series parallel combinations will lie in between. So the question is, in which arrangement is the current from the supply lowest and in which it is it highest? So the current is lowest in X and the current is highest in Y because Y is the parallel and X is the series. So lowest current is in X and the highest current is Y is option B option. So lowest current in X because resistance is largest in series combination for identical elements and highest current is in Y combination because resistance is smallest in parallel combination for identical elements. So option B is the correct option. Okay, next question. Next question is question number 3. The circuit diagram shows a parallel arrangement of resistors. P, Q, R and S represent the current at the points shown. Which statement is correct? Okay, if you see this diagram carefully, then you will come to a point that P is actually the total current flowing in this arrangement. So P current is the highest. P current is just coming from the battery and it is the highest current. And this current is divided into two parallel branches according to some ratio. That means that means Q is less than P and R is equal to S. Okay, because R and S are flowing through same 20 ohm resistor. R is equal to S and Q is less than P and so R is also less than P and S is also less than P. Okay, with this knowledge, which statement is correct? So of course, P is the total current and Q is the part current. So total is always greater than the part. So Q is a subset of P. So Q is smaller and P is the larger. So P is greater than Q is the correct option. Option A. So here you can see P is greater than Q and R is equal to S, and Q is greater than R as well. Why Q is greater than R? Because the Q is flowing through the 10 ohm resistor, whereas R is flowing through the 20 ohm resistor. So R is less and Q is higher. But these two are, both Q and R are parts. The whole current is P. So both parts, so P is equal to Q plus R. The total current divides itself into Q and R. So P is equal to Q plus R. Okay. So of course P is greater than Q because P is the whole current and Q is the part of that whole current. That's why P is greater than Q. Okay, next question. Question number 4. Which graph best represents how current I varies with voltage V in a component in which the resistance increases as the current increases? So if you see these various graphs, you can see in graph A, the resistance here is constant. The gradient, that is the ratio between y and x, that is current or V or I, is a constant ratio, and that graph is for resistance. So here in option A, R is constant. If you see option B, resistance is increasing. Resistance is increasing because resistance is R is equal to V over I. So here you can see, if the V over I value is increasing. And the third graph, C graph, here in this graph, resistance is decreasing because here also R is equal to V over I. So V over I is decreasing. So that's why R is decreasing in option C. So as per the question, the option B, R increases in B diagrams. Option B is the correct option. Question number 5. The diagram shows a circuit. The ammeter has negligible resistance. What is the resistance of the resistor R? So in through R, 0.5 ampere current is flowing. Okay, and the voltage of the battery is 3 volt. So we know the total voltage of the circuit, that is 3 volt. We know the total current flowing in this series combination is 0.5 ampere. So by Ohm's law, V over I is equal to resistance. So 3V over 0.5. 3V over 0.5 is the total resistance. That is 6 ohm. So 6 ohm should be equal to R plus 1. So R in this case is 5 ohm. R plus 1 is 3 over 0.5. That is the total resistance. And R is 5 ohm. 0.5 ampere current is same everywhere. In series path, the current remains the same. 0.5 ampere is the total current, and 3 volt is the total input voltage. Okay. Question number 6. Under which condition does Ohm's law apply? There is only one condition, that the physical quantity and temperature, that quantity should remain constant. This is the condition for the application of Ohm's law. The temperature should not vary. Okay, the temperature must be constant. Question number 7. An electrical quantity is defined as the energy converted by a source in driving a unit charge around a complete circuit. What is this quantity called? This quantity is electromotive force. Electromotive force provides the necessary energy to move a charge around a closed uh, in a complete circuit. So it's the energy, electromotive force. Work done in moving a charge of 1 coulomb through a circuit. So that energy is being supplied by the electromotive force. Okay. Question number 8. The diagram shows the current voltage graph for a length of resistance wire. Where can Ohm's law be applied to the wire? Ohm's law is applicable on the linear range, and from the diagram we can see xy is the linear range. So xy is a linear region, and Ohm's law is applicable in this xy linear region only. So option C, from x to y. After y, the non-linear region starts, and in non-linear region Ohm's law is not applicable. Question number 9. A wire has a resistance of 8 ohm. A second wire made of the same material has half the length and twice the cross-sectional area. What is the resistance of the second wire? Okay, same material means resistivity is same. So omitting resistivity rho in the formula for this particular case, the resistance of first wire is rho L over A, but we can omit the resistivity. So the resistance of first wire is L by A is equal to 8 ohm. It is given. So equation number 1. Now according to the statement of the question, the length of the second wire is L by 2. It is half of the first wire, whereas the cross sectional area of the second wire is twice. So it is 2A. So the resistance of the second wire is 1 half L over 2A. 1 half L is the length of the second wire and 2A is the cross sectional area. So it is 1/4 L by A. It is equation number 2. Now from equation number 1 we know that L by A is 8 ohm. So put the value of that L by A, which is equal to 8 ohm, in equation number 2. And after solving, the resistance of the second wire is 2 ohm. So option B, 2 ohm, is the correct option. Question number 10. Two resistors 6 ohm and 12 ohm are arranged in parallel. A potential difference is connected across the terminals X and Y. Okay, the current through the 6 ohm resistor is 4 ampere. What is the current in the ammeter? Ammeter is measuring the total current. 4 ampere is the branch current. 4 ampere is flowing through the 6 ohm. So we have to find another current which is flowing through the 12 ohm resistance. Then we sum up these two currents, and that will be the total current that is being measured by the ammeter. So first of all, 4 ampere is flowing through the 6 ohm resistor. So the voltage across the 6 ohm resistor will be 24 volt. V is equal to IR. And we also know that the voltage is same in parallel combination. That means 24 volt is also available across the 12 ohm resistor. So the current flowing through the 12 ohm resistor will be I is equal to V over R, that is 24 volt over 12 ohm, and that is 2 ampere. So I through 6 ohm is 4 ampere and I through 12 ohm resistor is 2 ampere. Now summing up these two branch currents, 4 ampere plus 2 ampere, which is equal to 6 ampere, is the total current that is being measured by the ammeter. So ammeter will measure 6 ampere. So option B.